Let's get our next speakers in. So let's welcome Dolis and Anusha. Welcome.
Hey, folks.
Hello, you are on screen. Good
Thank
to
you.
have you.
Thank you.
All right.
Good to be here.
I understand that we have two slide decks, and I will start with Dolis' slide deck or Dolis' screen. Correct?
Sure.
So we already running out of time, so I will not do some chit chat. I will just give you the floor, share the screen, and you two go ahead, and we will remove ourselves because you are way more interesting. Let's go ahead. Cheers.
Thank you. Hey, so welcome everyone. Welcome to our talk, Securing Kubernetes Manifest with Cosign and Kyverno. I'm Anusha. I'm a technical product manager at Nirmata.
Hi everyone, thank you for joining. My name is Dolis and I'm a customer success engineer in Nirmata. So today we are going to talk about how we can secure your Kubernetes manifest with Cosign and Kyverno. And these are a couple of the agendas or talk topics that we are going to cover in today's session. To start with, we will talk about what does a Kubernetes CI/CD workflow looks like in the Kubernetes world, or how different people are using CI/CD pipeline with different tools, and then why we need to sign anything. Where does signing and verify fits in entire these pipeline, and how can we sign and verify the container image? What are some of the projects and how they can help you? Along with that, Anusha will talk about a little best practices, and then we'll end up this presentation with a quick demo. So, starting with what does Kubernetes CI/CD pipeline looks like, you will see that this is what the CI/CD pipeline looks like today, which is nothing but a different stages tools used. So we usually there are different tools that are being used at each level, starting from storing the code in the repository to building and testing it, and then these all codes or these all build things are then consumed by your consumer. Now, with advanced technologies like containerization and Kubernetes, it makes it more complicated. Ensuring that you have the right security practice followed is often challenging. So once we have this pipeline, which we are aware of, how does it look? Why should we sign anything? And why should we even sign anything in, like, if we think about this, if we forget about the software for a moment and generally think about why we use signature, we will know that how important it is and why it is so necessary to provide trust into any process. So which narrows down to three things. That is, it signing anything provides authenticity, so where you can make sure that whether the data or payload which you are pulling is coming from an authentic source. It gives you that trust to trust that, okay, the data is coming from an authentic source. It provides you integrity, where you can make sure that the data is not tampered in between, and you can actually rely on the integrity of it. And finally, you can make sure that once you have sign anything, you can just not go back and you can change anything and come back. So changes like that can be, the updates or changes like that can be cannot happen once you sign anything. And in today's cloud native world, where a simple unit to start with is, we all start with building an image. So all we do is first we start building an image where we have all the dependencies and several other things we use to build that. Now, when we are using that image in our Kubernetes cluster, we are not only depending or relying on that image, but we are also trusting it. And not only that image, but we are also trusting the base image and all the code that it is included. Now, how do you make sure that the container image that you are running is authentic? If you think that the right tag will be enough to make sure you're using the right image, let me tell you, it is relatively easy to override a container registry or trick the system to think it is using the right image, whereas it is not. So that's where signing an image and even signing a YAML and verifying the same will help. With the help of some of the policies, will help you to enable the right check at your security system or at your entire CI/CD pipeline. So we understand why we need to sign anything. But how do you sign anything? What are the different ways you can sign anything? So what we can do is, the publishers or the artifact publishers can actually create a key pair, and you can use a private key to sign your images. You can then distribute a public key for your consumers, and the consumers can use this public key and actually authenticate whether the signed image is verified or not. Now, unfortunately, when you add these pieces, it's often hard to put together that we think it is. So that's where Sixstore helps. Sixstore is a set of open source project for signing and verifying and protecting your software. So where Cosign is a sub project which is specially targeted as signing and verifying a container image. It includes Cosign project to sign image and verify image, and it also encapsulates some of the logics specific to YAML and image signing and verification. So what you can do is, or what exactly, if you think about the CI/CD pipeline, taking a step back, going back into our previous conversation we've been having, is what you can do is you can have the cosign CLI to sign your images, and you can sign your images at the start of the pipeline. And what you can do is you can have Kyverno, which is running in your Kubernetes cluster, which will verify this image and make sure that whatever the images are, they are signed. And it will also block the unauthenticated or unauthorized images. And you can do this not only for the images, you can also do it for the payloads. You can do it for the approvals of the Git commit. You can also do it for the manifest to increase or enhance the security level. So a little bit about Kyverno. Kyverno is a Kubernetes native policy engine. It's the policies and reports that Kyverno deploys are Kubernetes resources. It runs as an admission controller, and it also has a CLI. So you can also use Kubernetes CLI in your pipeline, and you can verify all the deployment before you are deploying it on your Kubernetes cluster. And it also has a background scanner, so you can actually scan all the images that are running on your cluster. So you can scan the background, and it can Kyverno can create a report for you, so you can actually see what exactly is happening, what is failing, what are the images that are signed and what are not. Using Kyverno or using Kyverno policies, you can verify, mutate, and generate Kubernetes resources. So you can do a couple of things, couple of cool stuff using Kubernetes, using Kyverno policies, and all of this is in a simple YAML format. So you don't have to learn anything, or you don't have to learn a different language. If you know YAML and a Kubernetes, a little bit about conceptually, you know how it works, you should be good to write your policy from day one. And specifically this is integrated with Sixstore Cosign for image and YAML verification, which Anusha will later talk about, and show you a policy, how does it look. And it becomes really easy to actually verify an image, and you don't have to do a lot of things manually, which otherwise is the case. Okay, so I think we are good with why we need it and how we can do that. Now Anusha will cover some of the best practices and demo you quickly how you can actually sign and verify image in your cluster. Anusha, you're on mute. If you're
Anusha, oh, yeah, that's what I wanted to say. You're on mute, but
Every time. Okay. So yeah, thank you. I'm going to cover a little bit on the best practices that is followed in the industry today. So what does make every phase in the supply chain trustworthy? So this image is taken from a paper that was published by the CNCF tax security team. This paper was published last year. It's a good read. So I've also included the reference link. So do check it out. I particularly like this image because it clearly tells us what is software supply chain. It is analogous to our traditional supply chain, wherein you have a factory wherein you manufacture things, you package, you process, and then finally you ship it to the customer. Similarly, in software, we start with our source code. That is, whenever we write code, we not just write new stuff, we also import libraries so that those become our dependencies. Then we have build systems. So if we have a Docker file, we build a container image, we create all our release manifests. And then we either store it internally for internal consumption, or over a network in different repositories. And finally, your consumer, when you have to um, consume all these artifacts, you pull it from the internet and you deploy it in your target environment. This environment could be the public clouds or on-prem systems, but you have to get all these artifacts from the publisher. So each phase of this supply chain has to be secure. So in the recent past, all of the cyber attacks, if they have taught us anything, is that security should not be an afterthought. Security should be, included right from your design phase to your writing the code to build systems, and finally while deploying. So it has to be part of each and every phase in this supply chain. And also, it is important that all of these steps are automated, because it is not humanly possible for one person or one team to carry out all these steps. That is where there are several open source tools which help in automating different stages of this supply chain and add security to each of these phases. And in the demo today, we are going to look at two popular open source tools like Dolis mentioned. We are going to use Cosign to sign our container image. And then we are going to use Kyverno to verify that actually the signed image is what we are using in production. So let's quickly jump to the demo. I have a screen recording so that we don't, run over time. I'm going to walk you through this recording. So let me start. Yeah, so I have a simple hello.py file that just says hello world. And I have a Docker file that says copy this file and then execute the file. So this is the Cosign public key. So this is the public key that Dollis also mentioned that you need to distribute to your consumers. So using this public key, the consumer will verify that whatever was used to sign the image or an artifact is actually the same. So we can generate keys using Cosign. Here locally, I've generate using the generate key pair command, but it is integrated with a lot of things. You can use X509 certificates for signing. You can use AWS KMS and a lot other things. So this is the Kyverno policy. So there are a few parts in this I'm going to explain about. So this is a cluster policy. It means this policy is applicable throughout your cluster, irrespective of the namespace. And we name this policy check image, and the validation failure action is enforced. It means if there's a policy violation, the admission request is going to get rejected. And then we have kinds. That is, this particular policy is applicable on resource kinds, pods, and deployment. Kyverno is a policy engine which acts as an admission controller. So whenever you create a new pod or a deployment, this admission controller sees that, okay, this policy is deployed and there's a new incoming pod or a deployment. Does it pass the policy or not? If it passes, it admits the request. If it fails, it rejects the request. And then verify images is the key. So here we are using Cosign for signing the images, and Kyverno has integration with Cosign. And this is the particular key that you have to use in your policy, verify images. And then you give your image reference. So here I've stored the image in my Docker Hub repository. And this is the public key. So you have to tell your policy what is the public key to use, and it is the same public key that was generated by the Cosign key pair generate command. Now let's look at a deployment file. So this is your typical deployment file, and the image that I'm going to deploy in the cluster is the DevSecOps demo image. All right. Now that we have looked at all the files, we will build and push this image. So I'm pushing this to my local Docker Hub repo. Okay. So now let's just quickly verify. We see that the DevSecOps demo is indeed pushed with the tag 100. So now we have our setup ready, but now we need a cluster for it. So for the demo, we are going to create a kind cluster. And when the cluster is ready, we will start deploying policies and see what happens. So the nodes are ready. Kyverno is also available as a Helm chart. So for the demo, we are going to use Helm chart for installing Kyverno. So you add the repo, you update it, and then finally do a Helm install. You can see that I'm installing Kyverno in its own namespace Kyverno. It's a good practice, and setting the replica count to 3. So if you look at the pods in the Kyverno namespace, there should be 3 Kyverno pods. Yep, they're initializing. And once the Kyverno pods are ready, we are good to install the policies now. So just a quick recap of what we are going to install. So if we look at the check image policy, so this is a cluster policy and it's a DevSecOn demo, it's the correct image tag, and it's an enforce action. And the deployment, just making sure we are using the same image. Now that all the pods are running, we are going to install the policy in the cluster. So you apply the policy YAML. And now the setup is such that we have a kind cluster, we have Kyverno admission controller running, and we have installed our policy. But the image that we have pushed to Docker Hub doesn't have, it's not signed. So, but in our deployment, we are using the same DevSecOn demo 100 tag, but we have a cluster policy saying if the image is not signed, you have to deny the request. So let's try applying our deployment YAML. So typically all the deployment YAMLs in a production environment, you create a different namespace for that. So we are going to apply this deployment YAML in a prod namespace. So as you can see, Kyverno has denied the request, and the message that we get is it failed to verify image because there are no matching signatures. Now we are going to fix this. We are actually going to sign our image and then push the signature. So remember the cosign.key and cosign.pub that was generated. So we are actually going to make use of cosign.key now. So this is the command to sign your Docker images. So you give the private key and then you give the image name. So that's it. It's a cosign sign command signs the container image, and it also pushes the signature to your Docker repository. Now we'll refresh this to verify the signature is also pushed to the OCI repository. Yes. Now we'll go back and see, try to apply the deployment YAML again. Now all the policies are matching. We have a signature. We are using the image that is signed. So this should work. And yes, we have a deployment that is created. So that is the demo I had. I'm going to quickly switch back. Yes. So yes, so we saw that. So Dolis talked us through why securing images and manifests is important. We looked at the six-store project called Cosign and Kyverno, which is a CNCF incubating project, even though these are two completely different projects. And that is one of the benefits or advantages of open source, is that all these different projects, when used together, they can provide very powerful features. And how these tools actually complement to achieve a secure software supply chain. And we also looked at some of the best practices. Yeah, and if you want to get started with either of these projects, Kyverno has a set of sample policies. There are over 200 plus sample policies. You can take a look, and at least some of them should be readily usable for your production scenarios. And if you have any questions, you can join the Kyverno Slack channel. We are on the Kubernetes Slack and also on the CNCF Slack. Also, you can visit the SecStore official site to join the Slack channel, and they have a ton of good, cool projects under the SecStore community. And also, there's a very helpful Slack channel out there. Yeah, thank you.
All right, thank you so much, ladies. This was amazing, and thanks for the demo. That was smooth. I need to do that trick later on. Oh, let me remove your screen right away.
Oh,
I need
okay.
to, no worries. I need to do that trick where I just record it and that nothing happens, because Most of
Yeah,
the times,
because the
I
demo gods are never in my favor. So
most of the time I screw up with live demos. But thank you so much. If you have any questions for both of these ladies, or for one of these ladies, please feel free to put them in the Discord, because we are running a bit over time and I want to bring up the next speaker. So thank you, Anusha. Thank you, Dolis. This was great. Thank you.